Hello my dear students, welcome to this next video. In this video we are going to talk about a problem which was asked in GATE 2018 exam, question number 54 related to probability. So let us see what is this problem. It says that let x1 and x2 be independent geometric random variables with same probability mass function given by probability that capital X takes the value small k is p into 1 minus p raised to power k minus 1, where k can take values 1, 2, 3 and onwards, right. So, this is a discrete random variable. Then we have to tell what is the probability, conditional probability of x1 taking the value 2 given that x1 plus x2 equal to 4, correct up to 3 decimal places, right. Now, you are given the PDF, right. So, probabilities will come from here. Both x1 and x2 they are geometrically distributed random variables. So, if like you should know what are geometrically distributed random variables. So, so those random variables whose PDF looks like pq raised to power k minus 1, okay, where q is 1 minus p, right. So, this is the geometric random variable. Okay. So, we have to find the conditional probability. Now, you know that what is the probability of A given B, that is probability of A intersection B divided by probability of B. This is a formula for conditional probability, right. So, here that will be probability of A intersection B. So, this is A, this is B divided by probability of B. Now, if you look at the topmost numerator, so what is this? X1 is 2 and x1 plus x2 is 4. How is that possible? That is possible when x1 is 2 and x2 is also 2, right? And then in the denominator we have to combine all the cases where x1 plus x2 is 4. So, what are the possible ways for x1 and x2? The sum has to be 4. So, that is if x1 is 1 and x2 is 3, or x1 is 2 and x2 is 2, or x1 is 3 and x2 is 1. So, these are the possible ways for x1 plus x2 to be 4, right. So, now because these are independent random variables, right. So, both of them are independent random variables. So, we will convert the intersection into multiplication. So, this will be probability of x1 equal to 2 into probability of x2 equal to 2, and similarly here this will be probability of x1 equal to 1, x2 equal to 3, then x1 equal to 2 and x2 equal to 2 and x1 equal to 3 and x2 equal to 1. Right now, the PDF is given to be, if this is k, then the PDF is p into 1 minus pk, okay, k minus 1, right. So, that means this will be p into 1 minus p raised to power 2 minus 1, and here it will be p into 1 minus 2 raised to power 2 minus 1. So, that is p into 1 minus p into 1 minus p. So, that will be p square into 1 minus p square. Similarly, here it will be p into 1 minus p raised to power 1 minus 1. So, only p, and then here it will be p into 1 minus p raised to power 3 minus 1. So, that is p minus 1 minus p square. Similarly, here it is p into 1 minus p, and here it is p into 1 minus p. So, that will be p square into 1 minus p whole square. Similarly, here it will be p into 1 minus p raised to power 3 minus 1. Here it is p into 1 minus p raised to power 0. So, that will be p square into 1 minus p square. So, this will be p square into 1 minus p square, and in the denominator we have 3 terms, similar terms. So, it will be 3 times p square into 1 minus p square. So, you have 1 by 3. So, your answer will be 0.0333. No, not 0.0, 0.333. Okay. So, our answer would be 0.333. So, that is how you solve this problem, right. If you have any doubt, please write in the comment box. Please share this video and subscribe to this channel. Happy learning!